welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and today is going to be an important milestone for our series because in this video we are going to implement the sound in our game. So we are going to implement a basic sound system which is going to be a wrapper around the SFML audio libraries. We will also be taking a look at some of the important concepts of SFML audio which include the sound buffer, the actual sound object, and also the listener. So first of all, in order to use this, we are going to go under our makefile, and you want to make sure that you are linking SFML audio as well. Once you're doing that, we can go ahead and open up resources.h, and each file of the sound, which for example I've got a wave file format here, you can have mp3 or something. So every sound file basically can be loaded into an SFML sound buffer, and this sound buffer actually represents, if I open this up, you can see it represents a storage for the audio samples defining a sound. You can't actually play a sound buffer, you need to construct a sound from the sound buffer, but the sound buffer is what stores the actual sound. So let's go ahead and open up resources.cpp where we have just defined this. And in main.cpp, by the way, this is just a single sound right now, we can add more later, and this is called the weapon sound. In main.cpp, what we do is that we basically load this from the file of weapon.web which I've got, and if it fails we print an error message, but apart from that we just load this in main file. So now let's go ahead and open up sound.h, which is a new header. Now this is going to be a bit of an encapsulation system around our sound, and the reason we need to add this is because well, we want to be able to play sounds without much hassle. So this is essentially going to, because you need to construct a new sound object for playing a sound in SFML, so this is going to keep a list of sounds, and each time the play function is called, it will give a new sound, and once that sound is finished playing, we will just destroy that sound. And you can see that we have actually implemented two prototypes for the play function. One just takes a sound buffer, this will play the sound like normally. However, we've got another function which actually will play the sound in, you could say, 3D mode, so we'll be able to hear the sound like it is in 3D space around us. So let's open up sound.cpp, and in here you can see we have got a list of shared pointers of sounds here, and this list will just keep adding a new sound to this list whenever we want to play it, and once the sound stops, we are going to remove it from the list. So you can see this play function essentially just calls the other play function, but it sets the position to 0, and it sets the relative to be true, because this sound is now relative to the player. This means that the sound will be displayed just like without any 3D special effects, just like at full volume. So now let's look at the other actual play function, and in this play function we just create a new shared pointer of sound. We push that back onto our list of sounds that we've got here, and then we play that sound and we set its position to this position, and we set it relative to listener to true depending on this boolean variable that we have got. And of course the position is actually a vector 3f because this is in 3D space. So now we've got an update function. In this update function we just have a list of iterators of this sound here. By the way, we can actually make this a bit more concise by using the double type if you've got that. So we can basically say it like this, and this is actually going to be much better. So basically we get a list of iterators, we will call that to delete, and this will represent all of the sounds that we are supposed to delete, and we loop over each of our sounds, and if the sound status, we get the sound status, and if that is stop, then that means that the sound has finished playing, and then we just push it back onto our delete array here, list actually, and then we loop over each iterator in our delete, and then we erase that. And because the reason we have to do it this way is because you obviously cannot actually delete or erase an element while you're looping over, because that can cause problems. So we just store it in a separate list, and then we loop over that list and then delete it. So yeah, that's pretty awesome. This is how our basically sound is going to be handled, and as you can see, this is a pretty short system and pretty concise. It could be improved in a lot of ways, but it will be fine for our needs for now at least. So now let's open up the other file that we need. So let's open up game.cpp, and here we will look how this actually ties together. So we can open up game.h first of all, actually not game.h, game.cpp, and in here you can see that the only thing that we change is that when we are and then updating all of our things here, our animation as well. We just call sound update, and that's literally the only line we need to add in the game. We just need to update the sound to make sure that the unused sounds get deleted, or else you can get like hit a driver defined limit, and once you hit that limit it will start printing error messages and the next sounds will not play. So you need to make sure that you delete the sounds, actually free the memory of the sounds that you are no longer using. And the memory is of course handled automatically by the share pointer. We just need to remove it from the list. So now let's go on to player.cpp, where we are using this sound currently only for one thing. Later on we'll add more things. So you can see here what we do is we just play the sound here by using sound play, and we use our resources weapon sound here for the actual source. And here we've got three new function calls here which are related to SF listener. So SF listener basically is a class. Actually this is like a static only member class. It cannot be instantiated because, well, it can be instantiated but it's not supposed to be, because of course it doesn't actually have any member functions or variables or methods or anything. It only has static functions. So what this class basically does is that it represents the position of the listener that is listening to the sound in 3D space. So we can position the listener at different places to get the sound in different ways. Now the way I have positioned it is that we set the up vector of the listener always to point in the -1 z direction. You might think that it should actually be +1, but +1 leads to wrong results. We need to set it to -1, and then for the actual direction we just set it to the player's direction that we calculated here, so that the sound is correct according to that. And for the position we need to set the position here to the things x position and the things y position. So if I go ahead and run make right now, what you should see is that the sound is indeed correctly played. So if I go ahead and shoot my gun, you can see that we get the sound here which is correct, and I can shoot it again and I get the sound again without any issues. But of course the one problem that still exists is kind of that we actually don't have any way to visualize it in 3D. You can try setting the position of the sound somewhere else and you can see that it indeed works in 3D, but of course later on we'll add sounds from monsters and stuff, and then we'll be able to currently see it in 3D, because this sound is just displayed at the player's position. So if it's played at the player's position it actually doesn't have any effect, so it's just similar to playing it without any 3D effects. But it does work, and you can indeed verify this by changing the sound position. So you can, for example, go here and we can say that we want to display it at 2 and 2. So we need to specify that as well, which is going to be 0, or you might actually want to make it 0.5 because that would be a bit more accurate. Well, actually it should be 0 because we are setting the player's Z position to 0. So all sounds are equal to the player's Z position. Anyways, if I go ahead and run the sound now, what you should be able to see is that we get it from the left side. And if you've got a headphone and a stereo sound and everything, you can see that it does play the sound at the correct position. And if you've got like a 3D sound system, you should be able to see that. So anyways, this is gonna be pretty much it for this video. I'll see you in the next one, in which we'll start doing some more interesting stuff like implementing enemy behavior. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.